Hello, we would like to introduce you our digital story of network media. In our story, we would like to focus your attention on the main type of network media, which are cables. As you probably know, media is a part of physical layer of OCI model and is used to transfer data between network located devices. Different types of cables transfer data in various ways. The most common used type of network media are twisted pair cables. Electric current going through any wire causes a small magnetic field. That field interferes with adjacent wires, causing crosstalk. To help solve this issue, twisted pair cables use two wires in the same circuit twisted together so magnetic fields cancel each other out. This combination also protects them from some outside interference. There are two designs, unshielded and shielded. Unshielded type of cable, also known as an UTP, is designed to support telephone communications and modern networks. We can specify 7 categories of UTP cables. Category 1, used for only telephone signals. Category 2, transfer not higher than 4 megabits per second. Category 3, transfer not higher than 10 megabits per second. Category 4, transfer not higher than 16 megabits per second, suitable for token ring networks. Category 5, transfer not higher than 100 megabits per second. Category 5E, transfer not higher than 1000 megabits per second. Also Category 6, fastest standard for UTP using 24 gauge wires running at a speed up to 1000 megabits per second. So let's talk about UTP specification. Made from copper wiring, covered in plastic insulation, put into the twisted pairs to avoid interference and protected by plastic outer jacket against physical damage. Maximum length before needed to connect device is 100 meters. Transfer suitable between 4 megabits per second up to 1000 megabits per second. UTP cables are cheapest. It saves money because many buildings have already been wired with UTP, so this can save on costly rewiring, easy to set up and maintain. These are some of the reasons why they are so widely used at home and in the small LAN networks. Vulnerable to EMI, electromagnetic interference, and unfortunately can cover only the short distance. This is why it's rarely used in the WAN networks. Another type of twisted pair cable is STP, shielded twisted pair, mainly used in Ethernet networks using shielding, cancellation and wire twisting to reduce electrical interference and radio frequency interference from both outside and inside a cable. The STP specs are copper wiring, covered in plastic insulation, put into the twisted pairs, given individual pair shields of metallic foil, and also covered by an overall shield of metallic braid or foil to avoid any interference and protected by plastic outer jacket from damage. Maximum length up to 100 meters. Transfer rate is only 10 to 100 megabits per second. Still can be used same as UTP without any need of rewiring buildings. After all, STP is still reasonably cheap. Difficult to install, as metallic shielding has to be properly grounded at both ends to prevent it from acting like an antenna. Because of an extra cost and installation difficulties, it is rarely used in the Ethernet networks. In this part of our story, we would like to introduce you to coaxial cables, used for years to communicate all types of data. As such has become well-known technology. There are many sizes of coaxial cables. The largest at 1 centimeter, nicknamed thickness. It had increased transmission length and noise rejection, as such was specifically used as an Ethernet backbone cable. Second type of coaxial cable named thinnet at only 0.35 centimeter, very flexible because of its very thin construction. Their specs are single inner wire made up of copper, surrounded by flexible insulation, which has woven copper braid or metallic foil over. This is used as a second wire and shield to the inner wire. This is then covered with an insulating jacket for protection. Maximum length for thicknet is 500 meter and for thinnet is only 185 meter. Transmission speed is only between 10 to 100 megabits per second. More expensive than typical twisted pairs cables, with possible requirements of rewiring. Finet cables are cheap to install. More resistant against EMI than previously mentioned twisted pairs. The main disadvantages of coaxial cables are damage to the cable has chance of taking down the whole network and the requirement of grounded wire on each side, which is not often done properly. The result of that is increased interference and Finet rarely being used in Ethernet networks. Because of thickness of Finet, coaxial cables becomes more difficult to install, which makes it more expensive to use. As such, it is normally used when distance or EMI shielding is a specified requirement. Fiber optic is a next type of network media, which can be used in telecommunication and networking. We can recognize two types of fiber optics. Single mode uses lasers to generate light but only at a single wavelength. Can be used to cover longer distances. Multimode doesn't cover as long but transfer more data using LED technology with more wavelength. Fiber optic is made of very pure glass instead of a copper wire. Glass core is surrounded by cladding, which is made up of glass or plastic with low refraction index to trap the light within the core. This is called total internal reflection. The cladding is surrounded of plastic shield such as Kevlar, and by an insulating jacket. We can use Kevlar to cushion fragile glass fibers. The cable is occasionally strengthened by an additional stainless steel wire. Single mode maximum length is 60 plus km and for multimode is 2 km. 100 megabits per second to 100 gigabits per second are average speeds for these types of cables. Most important advantage of fiber optic cable is the ability to cover massive distances. For instance, recent Atlantic cables. Very high and secure data transfer compared to any cable. Because it is using light instead of electricity, doesn't affected by EMI. That type of cable, it's very hard to terminate, and because of its fragility, requires frequent maintenance, which increases already high costs. In the next chapter of our story, we would like to introduce you wireless technologies. This radio frequency and infrared-based media is the one of the most popular, which is part of the most modern technologies. There are four main types of wireless: WPAM, WLAN, WMAN, and WWAN. Firstly, we would like to talk about Wireless Personal Area Network, WPAN. This type of wireless is usually implemented in very small personal device networks, such as infrared or Bluetooth. Let's move to Wireless Local Area Networks, WLAN, which cover larger area, for instance, home network or small businesses networks using Wi-Fi 802.11 or Hyper-LAN. WMAN, which stands for Wireless Metropolitan Area Networks, WiMAX, which means Worldwide Interoperability for Microwave Access, with IEEE 802.16 standard defines point-to-multipoint broadband wireless. Finally, we can tell you about WWAN, Wireless Wide Area Networks, which is mostly used by mobile technology covering very large areas using GSM, GPRS, and UMTS 3G standards. Wireless technologies can create a network from 1 meter up to global distances using satellites, and with many free access hotspots, it is very widely used and available. Because of its nature, it does not require much cable installation. It is the one of the quickest evolving media technologies. The speed of wireless networks can vary between 1 to 54 megabits per second, so has a limited transfer speeds, and unfortunately it's one of the most expensive to set up, needing transmitter satellites, which can suffer from atmospheric interference. Also, there might get problems with security as signals can easily be intercepted and wireless devices easily accessed.